Alright, hell yeah. Statics. Alright, chapter 1, this is problem 11. You know what I mean? And hopefully we just kick this out pretty easily. We've been using that FLT system and then the MLT. You know what I mean? Or you could just say FLMT. You know, we're just using those 4 variables. In this one, we're not even using force. And in this one, we're not even using mass. We're basically just using length and time. So that just makes it pretty easy. And it says, hey, find the dimensions of the constants a and b in the following. And we got 2 equations. So a, we have v squared. Cool. And v is meters per second. It's a velocity. T is in seconds. And then x is in, like meters. You know what I mean? I like to use meters and seconds and newtons and, kilograms instead of the FLT and the MLT system. It kind of messes with me, but whatever. It's just a little bit harder. So anyway, so we got ax cubed plus bvt. Now the cool thing about this is if we're adding these components, they have to be the same units as this. So already we know what the units of this is because we know this one of these is m over s, so v is equal to length over time, and we know that v squared is l squared over t squared. Cool, so right on this side of the equation we have l squared over t squared. You know what I mean? And then so we can do the first one just right off the bat. We can just do them, but anyway, so it's like this side is going to equal this side, and we can just do one of them. So we can just put the a here, and then if we have x, that's equal to L, and if we have x cubed, that's equal to L cubed. Perfect. So we have L cubed. Now, the other way to do this is just solve for the variable right off the bat. So you could be like, hey, v squared is equal to ax cubed. Just solve for a. A is v squared over x cubed. Perfect. Now throw in the units, and you're going to get L squared over t squared. You know what I mean? Divided by L to the third. So those are going to cancel, and you're going to get 1 over t squared L. Cool. And another way to write this is just going to be, I bet you they'll do the L first in the back of the book, but you'll do L to the negative 1, t to the negative 2. That's the same way to write that one. And let's just double check. You know what I mean? Because we had it over here. The other way to do it is just like, hey, over here we need 2 L's. We have 3 L's over here. So this A is going to be divided by an L. Okay, we're set there. We have a T times squared over here, but it's on the bottom. So we need that on the bottom. Okay, perfect. And we just did that. You know what I mean? The other way to do it, same thing here. Get it to here and then separate variables. I'm just going to say A is equal to L squared over T squared, and then bring that puppy downstairs. Same thing, those cancel, and you're left with 1 over t squared over L, which we got. Booyah, we did that 100 different ways. All right, now for this, we got to solve for b. So this isn't the second problem. We just need to do this one. So how do you want to do it? You could do it all 3 ways. Let's just L squared over t squared. I'm trying to get just better at this. B is equal to L over t, and then we have time up top. So those are just going to cancel. And now we have BL. But we need 2 L's. So this B is going to have another L, and then we got to divide by t squared. All right, hell yeah. So that's going to be final answer for that one. But let's do it the different ways. I got 2 different sheets of paper. So we got v squared is equal to bvt. Let's just solve for b. So that's going to be v squared over vt. One of the v's cancel, and so we got b is equal to vt. And v is equal to length over time, and then you got time downstairs. So L over t squared. Booyah, we got it. And then you can do it 3 different ways, so go for it. But let's do the next problem. Because the next problem is kind of cool. We got x to the cubed is equal to a t e b t. Now, let's say this was x to the cubed is equal to a t sine of bt. You know what I mean? What do we know about like sine? A sine is just like a percentage, you know what I mean? And maybe this is the first time you've ever heard that. You know, if you have an angle here, the sine component's over here. And then let's say this is a ramp that's like 12 feet. Well, and this is 30 degrees. Well, what do we know about this? This is going to be 6 feet. And what do we know about this? Well, it's going to be 0.866 times 12 feet. I have no idea what that is. You know what I mean? But right here, we know that this is 50%. You know what I mean? That's what, yeah, sine of 30 is equal to 0.5. You know what I mean? Times 100%. Yeah, that's 50% of this length is that length. You know what I mean? And then sine of, cosine of 30 is 0.8866. That's 86.6% of this length is right there. You know what I mean? So this is dimensionless. You know what I mean? If you see sine of 30 is 0.5, this term is dimensionless. So this, you know, this doesn't add any dimension to the AT part. Same thing with this E. E to the BT is a dimensionless, you know what I mean, component. It's dimensionless. It drastically changes the equation, you know, whether it's going to be approaching something, because it limits it, you know, it can approach 0, you know what I mean, however this equation works. That's kind of why you would see this. You either have exponential growth, you know what I mean, this way, or, you know what I mean, if it's e to the negative bt, then you can be like, hey, we're rapidly approaching 0. You know what I mean? In one case, you're rapidly approaching infinity, so 1 over infinity, well, you're going to be rapidly approaching 0. So that's kind of the cool thing about that. All right, so we kind of learned about e to the bt, so we're not getting confused there. That was just kind of the cool part about this problem. And well, let's just solve for. So we know that this is just we can just kind of, you know, piece this part of the equation out, and we can just get, for unit-wise, x cubed has to equal at. You know what I mean? And then just solve for a. So we have x cubed over t, so that's going to be length cubed divided by time. All right, booyah, we solve for a. Okay, so now this has to be dimensionless. So one way to make something dimensionless is it has to equal 1. You know what I mean? Because it has no dimension. So 1 is equal to bt. Perfect. You know what I mean? So now, how would you solve for b? Well, you would go b is equal to 1 over t. Perfect. Now it's just 1 over time. That was real easy. You know, same thing here. If you had to solve for b, and this was a time, but it has to have no dimensions, b is 1 divided by time, the times cancel. That's why, there you go. So let's do that one more time, and we'll go, bt has to be kind of dimensionless. You know what I mean? So if we have bt, we have no t's on this side. You know what I mean? So b has to be 1 over t to cancel that t. That's another way to do it. All right, so we did it. b is equal to 1 over t. Done there, and a is L cubed over t. All right, hell yeah. Now, I think I met my goals for this problem. You know what I mean? One of the goals is I don't want to get too excited. I got a little bit excited on this one. You know what I mean? We'll work on that. Because else my voice is just going to get destroyed. But anyway, so, but hell yeah, we worked on that. We were a little scribbly. We got to work on that too. But anyway, thanks for joining me. Let's do another one.